Let's take a look at problem one off the review problem. So for the first two parts, we're comparing these two jobs. You've got a job in a clothing store, and it pays you a fixed amount each week, plus some commission, some extra amount for every dollar worth of clothing that you're selling. We've got these two jobs to compare, and I could write the equation for the amount you'd make. I've got a start value and a change. So in job one, you would make $200 plus 0.10 times, let's call it D. And in job two, you would make $160 plus 0.15 D, where D is equal to the dollars that you sold. So it's helpful to put those equations down. And we can ask, how much would you make if you made $500 or $1,000 if you sold, how much would you make if you sold $500 or $1,000 worth of clothing in each of these two jobs by taking 500 and plugging it into these two equations. So if you sell $500 worth of clothing, you will make 200 plus 0.1 times 500 in this first job, which works out to $250. Whereas for the second job, when you start out with a lower base pay, you would only make, it works out to be $235. That would be 160 plus 0.15 times 500. On the other hand, if you sell $1,000 worth of clothing, so we're going to plug in D is equal to 1,000 instead of D is equal to 500, then you will find that job one would pay you $300. That would be $200 plus an extra 100. And job two will turn out, plugging $1,000 into this, to pay $310. So if you sell more clothing, job two is better. And we can see that just by looking at these. If you don't sell anything, job one is better. You get $40 more a month, but job two is paying you a higher commission. So if you're going to sell a lot of clothing, this extra 5 cents per dollar of clothing that you sell is going to add up. And eventually, if you sell a lot of clothing, if you sell expensive clothing, job two is going to be the better one. So the question in part B asks us to figure that out. How much clothing do you have to sell before job two becomes the better one? And anytime I'm doing a problem like this, I like to sketch a graph of the two of them in order to keep track of what's going on. And I'm going to do job one in red and job two in green. So my graph would look like this. Notice I'm not putting in any numbers. I'm not plotting any points. Job one just starts out at 200. It should look like a straight increasing line. So that would be job one. And now I want to put job two on the same set of axes. It's going to start out lower down here at 160, but it's going to grow faster. So it's going to look something like that. And this aligns with what we said. If you sell a little clothing, job one is better. If you sell a lot of clothing, job two is better. And what we want to do is find that crossover point. Where's the change? And you do that by setting these two equal to one another. 200 plus 0.1 D equals 160 plus 0.15 D. Now, I'm going to do this with the algebra, but I'm also going to talk a little bit through what's going on. First of all, I need to get the D's to one side of the equation and the constants to the other. So I'm going to subtract 160 from both sides to get rid of that. And that will leave me with, I'll do this in two steps, 40 plus 0.1 D is equal to 0.15 D. I'd like to say that 40 means something. That 40 is how much more job two paid you at the start than job one. Before you sold anything, job two put you ahead by $40. So that's what that 40 is telling you. But now I'm going to subtract this 0.1 D from both sides to get the equation. 40 is equal to 0.05 D. And this number here is also telling me something. This 0.05 is telling me how much more job D pays for every dollar worth of clothing that I sold. So what we're looking at here is something which says job 1 starts out $40 ahead, but job 2 is catching up by 5 cents for every dollar worth of clothing that you sell. So how many dollars worth of clothing do you have to sell for that extra 5 cents to close the gap and exactly balance out what job one's situation? And that's what that equation is asking me to do. I divide both sides by 0.05 to isolate the D. That's saying how many 5 cents is, how many little 5 cents more per dollar that I sell do I need to add up to $40. And when I do that calculation, I get D is equal to $800. So pulling this all together, I would say if I sell less than $800, A is better, or job 1. If I sell more than $800, job 2 is better. So that's the sentence that really explains this whole situation. And it would be a good idea to take the opportunity to check this, to take $800 and plug it in to these two equations and check to be sure that you get the same answer in both of them. You do, but it's a good thing to check. Now I want to look at problem C. So here's part C of this problem. You've got a new job, which pays you $250 to start. They only give you 7 cents per dollar that you sell if you sell $3,000 worth of clothing or less. But if you sell more than $3,000 worth of clothing, then for every additional dollar, every dollar you sell after $3,000, your commission goes way up. You're doing well, and they're going to give you 20 cents for every dollar worth of clothing that you sell. So the question asks us to write this is a piecewise linear function, so it's going to be a 2-part equation, and it's going to look something like this. First, I just deal with this top part. Your pay is equal to, well, the top part says $250 plus 0.07D, as long as D is less than or equal to $3,000. And now, in order to deal with what happens at $3,000, I have to take this changeover value and plug it into that equation. And when I do, I see that at D is equal to $3,000. If I sell exactly $3,000 worth of clothing, I would make, just by plugging into that, $460. And I need to go figure that out, because that's where the second equation is going to start. The second equation says my pay is going to be $460 plus 20 cents per dollar worth of clothing that I sell, but only for the extra dollars, only for the dollars after that changeover point. So it will look like that if D is bigger than $3,000. So that would be my 2-part equation for how much I would get paid. The graph, well, it starts out at 250, so I'll label that. Oops, that's 250. It goes up until it reaches D is equal to 3,000. And at D is equal to 3,000, it bends, it starts to go up more steeply. So the graph would look something like that. And if I want to plug in what happens when D is equal to, what did I ask, 3,500? Well, that puts us into the second situation. So my pay would be $460 plus 20 cents times the extra $500 that I made. The $500 after the changeover point. So that would be 3,500 minus 3,000. And if you calculate that all out, you will get $560. So that's problem one.